Okay, there are a few things I'd like to talk about. Sorry, I have to resort to English.
You're welcome.
There are a few things. So here we are mainly talking about immunity and how to boost our immunity so that we can evade the potential viral attacks. But the problem with the immunity is there are two problems. One is it's a long process. You just cannot expect that you'll have a tablet of vitamin C today and it'll be protected for the entire day. All right? The second thing is, no matter whatever you practice or whatever Ayurvedic drugs you take, the effect of the Ayurvedic formulations or the effect of the practice that you're doing is very subjective because we are genetically very different from each other. So the effect of these practices or these drugs are very different. So our immune system, of course, there'll be some effect on the immune system, but the extent of the immune boost will be very different from person to person. And if this is the case, just imagine 100,000 viruses are attacking all of us. Our immune systems are all different. So we are going to react to these virus infections. Just imagining a very experimental condition where we are equally infected by the viruses. So maybe my immune system is moderately weak, so I'll be very infected. Your immune system is very good. You'll not show any sign of or signs or symptoms of this virus because your immune cells can cope up with the viral infections. Maybe for others, it'll be severe infection. So what will happen then? There are two things to combat viral infections. One is the prevention, and the second is the treatment. I'm not talking about the prevention here because there are many experts already talked about the different ways of preventing viral infection. Here we are talking about, rather I will be talking about the cure part, how to treat. If somebody is infected, will I teach the person how to do exercise or give some Ayurvedic medicine, or I'll readily find something which will clear off the virus from his body? This is where the cure part comes. Regarding the virus cure, coronavirus is a family which belongs to the SARS and MERS that broke out in 2002 and 2012 respectively. And for SARS, it's known that the virus binds to the surface receptor, which is angiotensin converting 2 receptor or S2 receptor. And for MERS, there's another one called DPP4. There are some drugs which are developed against these viruses, but you have to imagine that SARS went down and the pharma companies also lost interest in SARS. Therefore, they did not do any human trials on this drug. Okay, so that project was shelved. MERS is still continuing. There are very good studies on this MERS drugs, that is against the DPP4, but again, the clinical trials could not draw any conclusive results on it. There are other targets too. There are other drugs to revive reading, for example, interferons, plasma-based therapy, but none of them showed good promise against the coronavirus. So the bottom line is, for the coronavirus, we currently have no medication. Right. Vaccine is...
ये डॉक्टर साहब ने अभी जो कहा, ये हम बिल्कुल माने कि आज के दिन में कोई भी ट्रीटमेंट किसी भी स्पेशलिटी में नहीं अवेलेबल है और ये हम इसके ऊपर सहमत हैं.
So the best way to track the virus is, of course, vaccination. That's why all the children are vaccinated multiple times, no matter how many times they cry. They don't want to go to the pediatrician. At least I can share my experience with my daughters. They hate the pediatricians because they think that whenever they go to pediatricians, they'll be given some injections. But we take them there so that they are immunized against potential viral and bacterial threats. The problem with the RNA viruses, like influenza, dengue, is that the RNA is very prone to mutation, unlike the DNA viruses. So no matter if we have a vaccine today for influenza, that might give you some protection, but the same vaccine formulation will not work for the coming season. That's why you have to keep on building these vaccines every season. That has a tremendous impact or the burden on the economy. In a country like India, we cannot expect to immunize the entire population with the influenza vaccine every season because the virus mutates very fast. Sharing my personal experience, I was there in Switzerland, I was immunized because I walked on high-titer influenza virus. I was immunized, and after 2 months or 2.5 months, I had the worst flu ever because a Swiss flu evolved, and for that, remember, the vaccine that was formulated, that was available in the market was formulated at least 3-4 months in advance. But within these 3-4 months, a new virus came, and for that there was no protection. Okay, so this is a problem with the vaccine. Now, what are the other approaches? So one of the approaches is that if you target the virus with a drug or with a vaccine, the virus will keep on mutating. So there'll be always an arms race between the scientists and the doctors and the evolving viruses. So who wins, we never know. One of the promising approaches is to target the host genes. Host genes means we are humans and our genetic material is DNA. So DNA is very less prone to mutate. All right. So what happens? The viruses are inert particles. These are very small, maybe 100 to 150 nanometers in diameter. They have no signs of life if they're inert, if they're outside. But whenever they're inside, they show the signs of life. Like they show replication, they show transcription. They hijack the entire machinery of the human cells. So one of the very promising approaches is to target the host genes which are responsible for virus internalization and giving all the resources, all the support to the virus to thrive there and make thousands of copies of itself. So we have around 22,000 to 25,000 of genes, and there are efforts in different labs to hunt down the traitor genes which provide this assistance to the viruses. For influenza, there are different genetic sRNA screens. I was a part of one of such screens in collaboration with a pharma company, and we identify about 1,000 such genes. Now, identification of the gene is the starting part. Okay, so we have to understand the basic mechanisms of each of these genes, how these genes or how these proteins are providing assistance to the virus. So this is called host-directed therapy. The advantage of host-directed therapy is that if you find a drug which can block the activity of the host proteins, then no matter how many times the viruses are mutated, the virus is dependent, all kinds of viruses are of the same group are dependent on this particular protein. If you can temporarily block this protein, no matter how many times the viruses are mutating, they can still be blocked by blocking this particular protein. This is host-directed therapy, and in our lab we are currently working on influenza. We have plans to work on dengue as well. Unfortunately, we don't have the facility for coronavirus, otherwise I would be very tempted to work on corona. Yes. And yeah, so that is it. So this is one of the approaches which many labs are contemplating, and also there are drugs which are being designed specifically on the cellular proteins, and we are also doing some drug screening by targeting the cellular proteins rather than the viruses. This is where I stop. And thank you again for giving me this opportunity.